Hi, welcome. Today's lesson is on heating and cooling curves. We've already talked about how to calculate heat if you are taking, for instance, a candle and a beaker of water and you want to know how much heat is added to the water. Then you simply use the equation Q equals mc delta T. The mass of the water, the specific heat of the water, and the change in temperature of water. We've also talked about what happens if you are changing state, like you're boiling or melting or freezing. Then you can't use Q equals mc delta T because there is no change in temperature when something is changing state. So you have to use a new equation, and the one for boiling is right here, and that is Q equals N delta H V, and the little v stands for vaporization. So use that equation if you are going to be boiling the water. Well, what happens if you're going to be doing multiple things? Now, you're just not heating the water, or you're not just boiling the water. What happens if you're heating the water and then you're going to boil it? Or what happens if you're even starting out as ice and you're going to heat the ice and you're going to melt it and then it's going to become water and then you're going to boil it? How do you solve problems involving multiple phase changes? Well, I'm glad you asked, because that's what we're going to talk about today. So for instance, here's an example of a multiple step problem. It says how much energy in kilojoules is needed to heat 100 grams of ice. So it starts as ice from minus 10 degrees Celsius until it is all steam, all 100 grams is steam, at 120 degrees Celsius. So first of all, you need to understand really what's going on in the problem. First, you're going to add the heat to the ice, and the ice is going to warm up until it gets to 0 degrees, which is its melting point. Then all the ice is going to melt and going to stay at 0 degrees until it all melts. And then you have water at 0 degrees. Then you're going to heat up the water until it reaches its boiling point, which is 100 degrees Celsius. Then all the water is going to boil, and then you'd have to have some closed system so you could keep it all as steam. And then you keep heating it until the steam reaches 120 degrees. So what does that look like in a graph? So here's a graph of what happened. We start out as solid ice, somewhere at minus 10 degrees, so about here on this graph. And we're going to heat it up until it gets to 0 degrees, and then it's going to start to melt. So while it's melting, it's going to stay at 0 degrees until all of the ice is melted. And then it's going to go from here. It's going to raise in temperature, but now it's a liquid, and then now it's liquid water until it gets to 100 degrees, because that's the boiling point of water. Then it's going to stay at 100 degrees until it's all boiled, and then we're going to heat up the steam. So here it starts as a solid, melts, becomes a liquid, boils, and then becomes a gas. Now, we're going to have to do multiple steps because we can only use the Q equals mc delta T equation when it's a solid, or when it's a liquid, or when it's a gas. And when we do a solid or liquid or gas, there is a difference between these equations, and that's the C value. The C value changes for water if it's a solid, or if it's a liquid, or if it's a gas. We also have to worry about the melting and the boiling. Those are different equations also. So let's kind of work through this problem together. So the first part of the problem is just to heat up the ice. So really we're just answering this simple question: how much energy is used to heat up the 100 grams of ice from minus 10 to the melting point, which happens to be 0 degrees. And so that's the first part. So if we are not melting it yet, we can use the equation Q equals mc delta T. We just substitute in the numbers, and we get 2.09 kilojoules. Now that only works when it's a solid. Now it's at 0 degrees, it's going to start to melt. So what's our next step? Well, now we have to melt those 100 grams of ice. And now we're just answering this question really: how much energy is needed to melt 100 grams of ice once it's at 0 degrees? And the heat of fusion of water is 335 joules per gram. So now notice we have to use this new equation, Q equals m delta H. And it just says H here, but it's really m delta H. So we substitute our numbers and we get a value of 33.5 kilojoules. So now, if we remember what's happening, we took the 100 grams of ice, we got it to 0 degrees, and now we melted it. So now we've got all water. What do we do next? We have to heat up our water. So how much energy is needed to heat the water from 100 grams of water at 0 degrees to 100 grams of water at 100 degrees Celsius? So now it's all liquid water. We're not changing states, so we can use the Q equals mc delta T equation again. We substitute and we get an answer of 41.84. And notice the specific heat of water is different than that of ice. Ice was only 2 something, and now water is 4.184, so the different C values. So now it's all water at 100 degrees. Well, at 100 degrees, it's going to start to boil. So now how much energy does it take to boil all of this water? That's the next step. How much energy is needed to boil the 100 grams of water at 100 degrees? So now we need the heat of vaporization, which is 2,260 joules per gram, and we need a change in state equation, and this time it's the V, the vaporization. So we take 100 grams, multiply it by 2,260, and we get an answer of 226 kilojoules of energy. So now we've boiled the water, and now it's all steam, but we still have to heat the steam because we need it to get up to 120 degrees. So our last step is how much energy is needed to heat those 100 grams of steam from 100 degrees Celsius to 120 degrees Celsius. And the specific heat for water as a gas is once again lower, 2.09 joules per gram degrees Celsius. We use Q equals mc delta T again, and we get a final answer of 4.184 kilojoules. So let's kind of sum up what we just did. So the question looked like a simple one, but it became a 5-step question. How much energy is needed to heat 100 grams of ice from minus 10 degrees to steam at 120 degrees? So here are all the steps we did. We first heated the ice until it got to the melting point. We used this equation, and this is the value we got. Then we melted the ice, so we needed a new equation, so here it is, and this was our final answer. Then we had to heat up the water, because now it's all water, it's all melted, and we use the Q equals mc delta T again, and we get this as an answer. Then we had to boil the water and use Q equals m delta H, and we got 226 kilojoules, and finally it was all steam and we heated up the steam. So I add these 5 numbers together and I get a sum of 307.61, and that should say kilojoules. And now I have to round that number. So let's look at the values we have. When you add values, you have to look at the place. So what place do they all go to? Well, this only goes to the one place, so I round it to 308 kilojoules, and that is our final answer. So what do you have to do if you come up with a problem like this? Well, first of all, and if you haven't been taking notes, you want to definitely pause and write these down. You need to determine how many steps you're going to need in your problem. Is it one step? Is it just a liquid? Is it just a solid? Is it just a gas? Is it melting, just boiling? Or is it a combination of things? Are you changing states and heating up things? So make a graph like I made, and that looks kind of like this. So make a graph, all right? Label the boiling point and the melting point. So this is melting and this is boiling. And for water, it's easy. It's 0 and 110. But for other substances, you'd have to be given or look up their melting points or their boiling points, so you know where that point on the graph is. Then, after you have a graph that looks like that, find out where you're starting and where you're ending. And each time there's a change in the graph, that's a new step. Right? So if you started here and went here, you'd go 1, 2, 3 steps. If you were all in this region, you started here and went to here, that's just one step. So every time you change directions on this graph, you have to use a different equation and a different calculation. So each time you change in the graph, it requires a new step. You're going to use the Q equals MC delta T when you're heating just a solid, just a liquid, or just a gas, but you're not changing phases. And you have to use the right C value, the right specific heat value. The specific heat changes for many chemicals based on if it's a solid or liquid or a gas. Then you're going to use the Q equals N delta H or M delta H when you're melting or boiling, or doing the opposite if you're cooling something, which would be freezing and condensing. And then at the end, you're going to add all the steps together. So we're going to try these in class, so I hope you took good notes. Thanks for listening.